Hello everyone, welcome to the first chapter of Huawei HCIP OpenEULER course. This section, we will continue to introduce the common service management content of OpenEULER. In the previous section, we have learned about the Internet and the World Wide Web. We are familiar with the principles, package structure, request method, and session process of HTTP and HTTPS. And this section, we will describe the most typical HTTP application web service and the Apache HTTP service in detail.
From the previous introduction, I believe that you have a preliminary understanding of HTTP service. In fact, HTTP is a very common protocol in our working scenario, and one of the most successful HTTP applications is web server. So from now on, we will learn how to set up and configure a web server. Actually, from this picture, you can see the web server is typically between the user and the application server. If a user requests a statistic resources, the web server directly reads the related data from the storage and responds to the request. If the user requests a dynamic resources, the web server will forward the request to application server. After calculation, the application server returns the result to the web server. And finally, the web server returns the result to the user. For mainstream web server applications, including Nginx, Apache, and IIS, among them, IIS running on the Windows operating system. For Linux operating system, in terms of the popularity, from this picture, we can see that the Nginx and Apache occupy the top two web server applications, and Nginx has a clear advantages. In this chapter, we will learn how to set up a web server using Apache and Nginx. And before we get to setup and configuration, there are some basic concepts related to web servers that we need to understand. The first is web resources. A web server can provide both static resources and dynamic resources. For static resources can be directly accessed by user without being calculated by applications. Common static resources including text files, images, and video files. Dynamic resources require computation by the application server. During the calculation, the related data is read from the database, and then the final result is calculated. Because dynamic resources need to be calculated to obtain resources, there are generally various codes and scripts, and code language are also supported. Later, we will briefly introduce these, and also will introduce the application development by PHP. The second concept is that the way the web server accepts HTTP connections. There are multiple options here. The first is the single process I/O mode, in which the web server starts only one process to handle the HTTP request. In this mode, all requests wait for HTTP process to process. If there are a large number of HTTP requests, the client will feel that the speed of accessing the web server is very slow, and the experience is very bad. And when this only process crashes, the web server becomes unavailable. The second mode is multiple process I/O mode, That is, the web server will start multiple processes to process HTTP requests at the same time. In this mode, client requests are processed at the same time, which reduces the waiting time of the client. In addition, each thread is independent of each other and runs statically. However, if there is no request for processing, the process still occupies a corresponding hardware resources. Therefore, hardware resources required in this mode also need to be increased. The third is the multiplexing I/O mode, which is to start only one process for web service, but start multiple threads at the same time, and each thread can process a request. In this way, resources occupation caused by an idle process can be reduced. However, in this mode, a security problem caused by multiple threads needs to be considered. In addition, once the main process breaks down, all threads also break down, and stability of this server is relatively poor. The last mode is the multiplexing multiprocess mode. In this mode, the web server starts multiple processes, and each process contains multi-threads. This mode is very practical in scenarios with a large number of concurrent requests. For example, in the Internet scenario, this mode has the advantages of multiple process I/O and multiplexing I/O modes. However, the disadvantages of the two modes must be considered. And the third issue is the role of cookies and sessions in web service. When we introduced the characteristics of HTTP, we mentioned that HTTP is a stateless protocol. Therefore, when the obtained resources are required for subsequent HTTP access, the clients need to resend a response request to the server. This leads to a waste of resources. Therefore, the cookies and session mechanism are added to the web server to manage sessions and save the status. The cookies come from the setCookie field in the web server response handler. This field is constructed by the application developer on the server. After receiving a response from the server, the client saves this file locally. When the client accesses the server later, the client automatically carries the cookies information of this field. After receiving the request carrying the cookie, the server continuously the previous session. In this way, resources are not wasted. However, if the cookie's data is large, bandwidth resources are wasted. At the same time, if the cookies contains authentication information, it will also bring security risks. So the session mechanism is developed. In the session mechanism, after receiving a request from the client, the server generates a session ID and a corresponding value. The value is stored on the server, and the session ID is returned to the client. For subsequent access, the client only needs to carry the session ID, and the server will find the corresponding value and continue the session. This reduces the bandwidth usage and ensures the information security. Currently, the cookie and session mechanism are usually used together, but this is not mandatory. Okay, finally, let's look at the web server response code. As we mentioned in the HTTP packet structure, the header of the response message contains the status code of the web server, and this slide describes the common status code. For example, here, from 100 to 199, it means the incremental status code, and from 200 it's success status code. From 300 it's redirection status code, and 400 it indicates client error status code. From 500 it indicates server error status code. And here we also list some common status codes as an example. For example, if you receive 200 OK message, it indicates that the connection is normal. If you received 403 forbidden message, indicates that the access is denied. If 404 not found message, indicates that the server cannot find the requested resources. If it's 503 server unavailable, indicates that the server is not ready to handle the request from the client, but you can try to refresh and resend a new request later. And final one, 504 gateway timeout. It indicates that the server did not get a response in time from the upstream server.
This section will describe the most successful HTTP server, the web server, and the mode of receiving HTTP connections, cookies, sessions, and the response codes. Next, we will look at the Apache HTTP server and its key features. Thank you for watching.